Okay, as quickly as possible. This is the Transformers PowerPoint National Grid. So again, you've got the PowerPoint, and then you've got your Transformers National Grid doc to fill in the answers. So, voltage of an alternating current can be changed using a device called a transformer. Transformer, we've got two coils wound around a soft iron core. The alternating current, and it always has to be alternating current, in the primary coil produces an alternating magnetic field. If it was direct current, the magnetic field would be like a bar magnet and it would be stationary. But the alternating current makes an alternating magnetic field which moves. This alternating magnetic field is moving inside the iron core, so it then produces an alternating magnetic field is inside the secondary coil, and having a moving field inside a coil, we get current induced in the secondary coil. So alternating current in the primary and alternating current comes out in the secondary. Notice that there's no actual physical connection for current to flow between the two. For example, when you have your rechargeable toothbrush, you'll see it's plastic, and you put it on the side of a little plastic stand. It's all plastic. Or there's a transformer, the primary coil is inside the bit you plug into the socket, and the secondary coil is inside your toothbrush. And the electrical energy is transferred across the space by the magnetic field. So the voltage induced depends on the number of turns in the primary and the secondary coil. If we have more turns on the secondary coil than we have on the primary coil, then we call it a step-up transformer, because what happens is the voltage increases. If we have more turns on the primary coil than we have on the secondary coil, we call it a step-down transformer, because the voltage decreases. Now we'll do some exercises with those formulas next lesson, which will help you understand why we're doing this, and put some numbers onto what's happening. Now, for example, the old televisions, if you've ever seen these with a glass front, and they're quite wide, they're quite deep, not flat televisions, they needed very high voltage to work, because they had an electron gun that fired electrons at the screen to make the screen light up. That needed a high voltage, so they had a step-up transformer inside. Whereas these transformers that here in Spain, you see them inside buildings, but sometimes you hear them humming away. These outdoor transformers are taking very high voltage from the electricity grid, the distribution grid, and bring it down to lower voltage for our houses. We call this step-down transformer. So, how does it work? In the power station, what we've got is a generator that produces at 20,000 volts. The power that might be coming out of the power station might be 500 megawatts. So the current that's coming out of the power station, 20,000 amps, which causes quite a lot of heating of the wires that it's travelling through. So what we do, we have a step-up transformer that takes 20,000 volts to 400,000 volts to put into the power lines, and what that will do is reduce the current, so reduce the heating effect and reduce the energy that's being lost. So 400,000 volts travelling through the power lines maximum, low current, very high voltage, which means less energy lost. When we get to factories, for example, we might have factories and machines that are using 33,000 volts, or electric distribution, the power lines in the towns and stuff that have 20,000 volts, so we'll have a step-down transformer to go from 400,000 to 30 or 20,000 volts. And then to get into our houses, what we need to do for safety is drop down to about 230 volts, because if not, 20,000 volts will jump through the air, and that would mean if we had 20,000 volts in the sockets in our houses, the electrical current would jump out half a metre through you down to the earth and electrocute you. So you have to be very careful with electrical sockets if that were the case. 230 volts won't jump through the air, but it will go through if you touch a live wire. So, what is the order? Here we've got power station, national grid, step down transformer, power inspector, step up. What I want you to do is put this in your Google Doc here, got those into order. Before as well, put down the voltages that we have in different places. And I won't solve it because I'll let you do it. Here we've got some definitions to write down and some anagrams. If you want to put these in your Google Doc, please. There's the first one. If you pause the video. Whoops. Second one. So pause the video and look at that one. Try and put it into the real world. Third one. Fourth one. Fifth one. Sixth one. Seventh one. Eighth. Ninth one. 10th one. 11th one. So, for each of those, pause the video and write it down. And then, quick quiz. So, I'll go through the quiz now, and you can write the answers in your Google Doc, but I think as well I'll put these into Google Forms. So, what are the operating voltage and frequency of mains electricity? Write down your answer. Write down if you got it right or wrong. I won't correct them if you are watching the video. Why is alternating current used for mains electricity? Pause the video, write it down in Google Doc. Which of the following is not an electrical safety device? Pause the video, write it down in your Google Doc. What is a transformer used for? The kettle has an operating current of 6.7 amps. Which type of fuse should it be fitted with? If an electric fan has an operating current of 3.5 volts, which type of fuse should it be fitted with? Which of the following statements about mains electricity is false? Which of the following is not a common type of fuse? What does a step-up transformer do to the voltage of electricity produced by a power station? Which of the following is an advantage of a residual current circuit breaker when compared to a normal circuit breaker? Okay.